the soil is getting tired, and then the nutrients efficiency uptake of the crop is not as good as before. Hence, it creates a whole bunch of problems. One of it is sustainability angle, and another one is basically the economical angle. And our solutions is trying to repair that. Basically, how to make things balance. It's not that we are eliminating the usage of chemical fertilizers. We're trying to make it more efficient. How we make things balance, and then things are better economically, and the yield is healthier as well.
Welcome to the Indo-European Bridge. Today I'm joined by Qurrat Abu Ayub, CEO and founder of PT Tana Makmur. Abu, it is a great pleasure having you on the Indo-European Bridge. Let's start with a short introduction. Who's actually Abu?
Thank you so much, Timo. Thank you so much for the platform. I think it's 2 weeks back we met the first time and shared a bit about what I'm building. But to your questions, who is Abu? Basically, I like to see myself as a venture builder, an operator. For the longest time, I've been operating and building a venture and business models essentially within a startup and tech ecosystem in Indonesia. So I started off being a business strategist, building inside Gojek, basically. So back then, Gojek was hyper experimenting about so many things, and among some of those, I think 7 products, they were part of my work. So I have my footprints there, and I have my fingerprints there. So I did Gojek for 3 years, and after that, I jumped ship and built something else called Pinhome. So it's a property tech company, one of the biggest and fastest growing in Indonesia now. We were doing property buying, selling, and property service as well. So I was serving as one of the founding management, chief strategy officer, essentially. Pretty much the same with what I was doing at Gojek, but more hands-on experience building something from 0 to 1, and expecting what we're building to be heavily impactful for the society, especially in property and or property service, where job are usually informal and uncertain. So the platform is intended to make things or job more certain in property and real estate sector. So that's something that I've been building and involving at for the past, I think, 10 years. Now, still a venture builder, still an operator, but building my own. So we call it Tana Lab, essentially a biotech lab. Pretty much a shift from what I've been exposed to, but still it's intersections of leveraging technology, trying to disrupt, well, not necessarily disrupting, but maybe trying to regenerate the archaic sector like agriculture, and in impactful ways. I guess that's how I'd like to call myself as a venture builder.
Okay, thank you for the introduction, Abu here, in that respect. So, what actually has inspired you to found now PT Tana Makmur?
Interesting questions. There are a couple of things as a convergence, basically, both internally and externally as well. I think first and foremost, I think personally I see something meaningful is built from within. So there has to be something that drives you inside of you to build this, right? So in my case, basically, I was driven with my childhood dream as a scientist. I want to be a scientist for the longest time. But then the path led me to a different ways where I studied international relations, politics, and then I ended up in a business as my day-to-day life. But then I kept that dream for the longest time, and I guess building a business in a field of science is a good intersections basically, right? So pretty much I'm living my dream now. So the first one is basically my childhood dream. But then second of all is my desire to build something impactful. Um, when it comes to impact, I reflect on myself. What is the most impactful that I could be? In what sector, in what angle, and how to address it. And that come to mind that is agriculture, because when we're talking agriculture or food system in our daily life, that's exactly what we're consuming, right? And there's systemic problems, I guess, in the way we run things. And I believe the convergence of technology and science and whatever things that currently in trending, like AI and everything, which is something that I've been exposed to, right? Because I've been in tech industry for the past 10 years. I guess I can bring that expertise into agriculture. And another side of things that I got interested in and exposed to is basically sustainability. How to run things sustainably, and yeah, that can be run and driven by science. So the main thesis is if we are able to build a solutions driven by sustainability and science in agriculture, we would be able to make a dent to make the progress and process better in agriculture, and that's what drives me. So I guess all of those converge into the idea of Tana Lab.
Yeah. Okay. Thank you for sharing this. And one factor might be you were mentioning, sustainability, building something impactful.
Yeah.
So if we look about agriculture itself, so for many decades already, we are relying here on chemicals. So why are we hitting the breaking point in modern agriculture right now?
Yeah, I think first and foremost, you mentioned it because for many decades we've been using chemical fertilizers, and it's not that it's bad. I think chemical fertilizers is the innovations that we need and still need it. Basically, it's a breakthrough back then because of green revolutions in the U.S. and also the green revolutions in Asia, part of Asia, and also obviously Indonesia. The innovations of usage of chemical fertilizers have been helping a lot of people to have access to food, right? Because that's exactly what people needed previously. But then over the time, I think because aspects of our life, they are multidimensional. So it cannot be just chemicals that we are putting attention to. And the Mother Earth or the soil on its own, they have their life inside of it. They have biology, they have physics, law of physics running, obviously, if we're talking about science. And those heavy chemicals exposure over the consistent long period of time makes the soil tired, for sure. Why? Because the chemical compounds builds up inside the soil, obviously will intervene with the biological system, the microbiome inside the soil. And when the tiniest organisms disrupted, that will change the entire ecosystem inside the soil as well. So that's what push the soil into the breaking point, essentially, because we intervene with the microbiology. You have less microbes in the soil that is very functional and very useful for the nutrient cyclings and for the nutrient uptakes for the plants, right? Because of that, now the chemical fertilizers efficiency has been decreasing over the time. Imagine in the past 25 years in Indonesia alone, when it comes to chemical fertilizers usage, it has been increasing pretty much 3x. So 3 times more than what we needed before, right? But then even when the chemical fertilizers usage is increasing, but its efficiency is decreasing, basically almost 50%, which means you need 2x of chemical fertilizers more than 25 years ago to grow the same yield at the same land, right? So not only that it's an environmental problem, but it's also an economical problem because it's not economical to do that, right? So that what pushed the breaking point because the heavy usage of chemical fertilizers, and the soil is getting tired, and then the nutrients efficiency uptake of the crop is not as good as before. Hence, it creates a whole bunch of problems. One of it is sustainability angle, and another one is basically the economical angle. And our solutions is trying to repair that. Basically, how to make things balance. It's not that we are eliminating the usage of chemical fertilizers. We're trying to make it more efficient. How we make things balance, and then things are better economically, and the yield is healthier as well.
Okay, thank you for sharing this. So this might be then also a kind of the difference here, right? When it comes to how you actually operate then from a traditional, so-called traditional fertilizer or input company as well, right? Based on the focus and everything.
Yeah.
Let's talk also about precision biology. Yeah. So based on my understanding, Abu, you are actually also promising for any crop, any pathogen, any soil. Yeah. So you have there some promises that it comes actually with a level of precision as well in a biological system. Yeah. So how can you actually achieve this level of precision?
Yeah, interesting questions. That's exactly our value propositions through Tana Lab, right? But I guess the main, um, I would say the fundamentals to achieve that is basically rooted in the advancement of technology for the past, I think, 5-10 years. If we look into the biology of things, and I think biotech in general, I think we feel it, that for the past 5 years, 10 years, the advancements has been really, really rapid, Timo. It's being driven by several stuff. But the thing that we can see is basically from COVID, how could you generate a vaccine of a very potent virus in a fast manner, right? Because of the urgency. And people were working so hard to push that out and trying to basically mitigate that. That's one. So there's been an urgency in pushing biotech forwards. Second is basically because of AI. Biology is one of the most complex, basically because a lot of variables inside of it, and it's quite abstract because you cannot see the biology. But then because of AI, you can build the model. You can now understand more predictions and everything. So AI helps with that process, and we embed all of that into the way we built our process and the way we build our product now in Tana Lab. So our core belief, soil is programmable, basically just like any software. Soil is programmable. We just need to understand what constitutes soil and what drives that particular variables. So in our approach to make it precise, precision biology, we ensure that soil is programmable in the way that in 3 steps. So what we do is basically we try to decoding the soil. So what constitutes fertile soil? What's happening in high salinity soil, right? So we decode their particular conditions. And then second, we encode things. So imagine if we already understand the data, we already understand the conditions. We just like programming, we're trying to understand what drives what, right? And in our thesis, basically, one of the Pareto that drives the changes in soil, both in biology, chemical, and physical aspect of it, is basically microbiology. So the microbes, the small things, basically inside the soil. So we believe that if we are able to identify what microbes drives what, then that will encodes and becomes our agent. And lastly is basically we deploy through recoding the soil. So that's where the magic happens actually, when we have a very specific microbes and then we deploy that into the soil, then the microbes will be our agent of change inside the soil to basically deliver that precision biology. So I guess that's where things are being programmed. And obviously, like what I mentioned, AI is driving a lot of stuff. And in our case, we're building our backbone AI as well, leveraging frontier AI on how to make the mix and match of the microbes more precision. Because when we're talking about microbes, we cannot mix and match that just randomly, right? We need to make sure that each microbes will interact really well, not only one another, but also in the soil. How might that impact the physical, biological, the chemical compound within the soil and for the crops? So that's how we do it. So we leverage AI, we decode the soil, we make it more programmable.
Yeah, thank you on that. Okay, so well understood. Yeah, so this is actually then the way how you rebuild the soil's immunity and the immune system itself. And it's definitely also clear that this is a scientific breakthrough itself. But science in a lab is one thing. Taking it to the field is another thing.
That's true.
Let's talk about the tech side. So you were actually already talking about making use of AI and the data itself. So to predict and optimize this microbial interactions itself, right?
Yeah.
So, but what does it actually mean for a farmer? Yeah, when we talk about your solution. So how can actually a farmer benefit from your solution when we talk about AI?
Yeah. Very, very good questions and very contextual to conditions in agriculture, especially in Indonesia, when we cannot really come in and then say that, hey, use this AI, right? And hey, there is this platform that can help you. That's not how it works. Not in agriculture, not especially in Indonesia. So what we do is we're trying to downstream our insights from our lab into a product that is very much easy to use by the farmers. So there are 3 pillars that we built basically inside Tana Lab. So we built feed, protect, and detect. That's how we call it. So we feed the soil and we feed the crop by microbiology enhanced fertilizations, basically. So we have a biological carrier infused with our microbes. So and that becomes a very useful and very powerful fertilizations and powered by microbes and to be deployed by the farmers. It's easy. Why? Because it's just it's working just like any other fertilizations, right? So farmers don't need to reinvent how do I use this? Is it new technology? So it's not a new novel technology that they need to learn and relearn. It's something that they've been doing. We just modify it in a way that is more sustainable. So that's the first pillar. The second pillar is basically protect. So protect is usually farmers, they use a fungicide, pesticide, and everything. What we come up with is how if we change what they've been using with microbially enhanced biofungicide or biocontrol. So it's something they've been using anyway. We just create a different products that is obviously one we expect is way better in terms of working against the pathogens, but then at the same time it's more sustainable, and hopefully we would hit a point where economically it's also cheaper and at least competitive with the market. So that's the second pillar. The third pillar is the most, I would say, novel, the newest in terms of agricultural practice, especially in Indonesia, is the detection. Much like any health, in human health, animal health, early detections is always better, right? Because you prevent like higher risk. Basically, when the earlier you know there's a certain symptoms of a certain health problems or disease, then the earlier you can treat them. In agriculture, now in Indonesia, there is no detection process, so you always feel the loss later, and then you regret it, right? So how if we are able to bring in molecular diagnostic, just like how you do COVID testing. So as easy as rapid testing PCR, you test the seed, you test the soil, you test the crops, having a certain protocol to test it in a obviously, hopefully, economical way and easy way, and then you understand, oh, I have a risk of a certain disease, fusarium in chili, for example, or ganoderma in palm oil. Then you can treat them immediately before it spreads, right? And that's how you actually build the precision. And you combine the three pillars, then you have optimized protocols to make sure that your farm is operated in a sustainable way, but at the same time optimized for yield in a sustainable way as well.
Okay. I would say advantages are clear, benefits for the farmers itself. But let's talk also about the challenges. Yeah. Having the solution is one thing.
Yeah.
But make it happen is another thing.
That's true.
So what are the challenges, or how is it when it comes to convincing then the farmers itself, related to your solution?
Yeah, definitely, Timo. I think when we're talking about agriculture, it's one of the toughest ecosystem, but I would say it would be one of the most rewarding to crack and to unlock as well, because the impact is not only economical, but the impact is gonna be very much societal level, right? Because it's a food system. It will make jobs better. It would make food healthier and such. But again, it's one of the toughest. Some challenges is basically because of the farmers are an aging populations, whereby the type of people are pretty much not well educated to begin with, unfortunately, especially in Indonesia. So the convincing needs more time, the educations and everything. In our case, what we want to do is a small step in creating a model for them to see and to get a confidence on, because you cannot basically speak in front of them, like preaching, selling your science and technology, and then hoping that they would understand, right? What they need is basically they need visual, they need real impact. So what we do is in two ways, basically. Yes, we're trying to build and sell the products, but then at the same time we are trying to operate it on our own as well, because we cannot expect farmers to just follow through and the result will be there, right? What we need to show is, hey, we operate our own land, where all protocols are in place, and then you see the yield is up by 50%. And not to mention, because of it's being built in a more sustainable way, there is a high value market that you can unlock, especially in organic market, especially in Chile, for example, right? So that's basically one of the way to do it. But when we're talking about business strategy, we're very much pragmatic in the way that we approach the market. We don't immediately go to all the farmers and then try to just enter the market foolishly, right? So we pick and choose what kind of crops and what kind of farms, what kind of communities that we want to engage with first as our early adopters. So that's why we come in with two main crops first. Crops that is first and foremost high value. It's also high demand. At the same time, it's also highly chemically exposed crops. So we come up with top two, which is chili in Indonesia, because everyone loves chili here, and it's high value for sure. And the second one is basically palm oil. Palm oil is one of the most valuable crops in the world, and Indonesia is the top one producers of palm oil. But there are lots of sustainability problems, economical problems on the ground, and disease problem. And we think we would be able to address that if we are able to program the soil. Right. So those two, the barrier to entry in terms of educating the farmers is relatively easier than the rest of like rice or any other low value crops. So that's why we pick and choose our battle, strategically speaking. Yeah.
Yeah. Okay, great. You have the science and the technology. Now let's talk about the growth phase and the partners you're looking for. So you are scaling Tana Makmur. Yeah, definitely. What does the go-to-market strategy look like for the next 18 months as well?
First, the strategy that we're looking into is basically trying to empower our operations with capital. Obviously, in any business operations, we need capital to do it, right? So that's why our very first strategy is deploying fundraising. Now we are in the middle of fundraising, of pre-seed fundraising. Actually, we're raising around 600K USD that would be able to basically push our products out at scale. Basically, all the three of them. So the feed product, the protect products, and the molecular diagnostic detect products. So we want to basically deploy that within the 12 to 18 months from now. So within that time period, if we have the capital, we would be able to push that. Second, basically, we would be able to reach the scale so that it can basically kickstart the engine of that revenue. Basically, so most of the capital that we get out of the pre-seed will be used as a working capital, basically, because we believe that this is not just a tech business, this is a revenue generating tech business. So the investment has to be put back into a working capital that will generate revenue, right? So that's the second, I would say, strategy. The third one is basically we are doing project financing. And this is very interesting, and this is correlated with our strategy in terms of entering the market. We are operating farms, and we open project financing basically on the site. Smaller ticket size, basically on the range of 50K to 100K, basically running 5 hectares, probably up to 10 hectares of land. Specific crops, we start with chili, for example, doing it with our protocols. And this becomes a completely revenue and cash flow generating project, essentially. Because chili cycle of planting is basically around 4 to 6 months. So you plant now, and then 4 months later, it's already first harvest, and then 8 months to 9 months of you can still harvest for the second times, basically. So 1 year you can harvest 2 times, because 2 cycles. So we hope that the project financing would be something valuable for investors, basically financiers, come in, help with the land plot through financing of a regenerative agriculture that we are running as an operator, and then we pay back accordingly each cycle, right? So this is not an equity level of investment. This is more of a project financing, and that way it will not only generating cash for us and for investor as an upside. But that becomes a proof of concept of our product as well. Yeah.
Yeah. Okay. Thank you for sharing this as well here. These insights and very interesting, Abu. So maybe also to share from your end, why is it now the critical point to join your company as an investor?
First, I think look into the food system, basically, right? When we're talking about food, 95% of our food comes from the soil. We cannot deny that, and it's inevitable. I think now we are trying to basically grow food vertically. We're trying to maybe grow food on the lab and such. But I think in the next 40 to 50 years, we're still going to eat food coming out of the soil, right? But the problem is really clear. The soil is not the same anymore. It's urgent for us to solve that particular problem. And if not, then we're going to go into a spiral of food crisis very soon. So innovations in soil is needed. It's no longer about the chemical. The chemical was the innovations in the past, and it has worked when it's most needed. Right now, we need another innovations where it's driven by biology, where it's basically powered by technology, and that's exactly the intersections that we're currently building, basically. So that's one. Second, Tana, we are operated and built by experienced operator, me myself, and then my co-founder, a environmental microbiologist, basically, a scientist on her own, and we are very passionate in doing this. With combined network and brand power, we think we have enough of what's needed basically to enter. Third is probably in terms of operating model and business model. We've seen enough agriculture and technology company for the past 10 years in Indonesia. We've seen what makes and breaks them, basically. We tried to address the market in different way. We understand enough that technology alone is not the play here. It's not gonna generating enough impact on the ground if nobody is using your products and nobody understand your products, right? So what our strategy is pretty clear. Our strategy is to be able to have a product easy to use, not introducing or reinventing the wheel on the ground. Just have a product that farmers immediately can use, right? Very easy. So that's one. Second is basically to build our own operating system, which is the farm operated by us, and that's what makes lab to farm closer. So usually when we're talking about innovation, it takes a long time to basically get on the ground and generate the impact. We cut that particular process and combine. We hope that this is a viable business, basically, that is not only breakthrough, but also impactful, and having that cash flow mindset in building this is very important, because at the end of the day, when we're talking about business, we are talking about generating value, and one of the value is basically the monetary value, and we keep ourselves pragmatic enough to make sure that we can create that value and capture that value. So we're not only like creating a bunch of innovations without being able to capture the value. So yeah, I guess that's how we think we are viable.
Yeah. Okay. Let's also look a few years ahead. Yeah. So we look now 5 years ahead. What is the environmental and economic footprint you are aiming to leave behind?
The environmental footprint, basically we measure it through the usage of chemicals, basically. Again, we don't want to replace chemicals. We want to make chemicals more efficient. If chemicals more efficient, then it becomes more environmentally friendly. You only use chemical when it's needed, right? So at the dosage that is needed as well. Just like when we're talking about human health, you when you take certain antibiotics, for example, you take it in a certain dosage, right? You don't take it like a bunch of them at the same time. Obviously, you're going to go on overdose, and that's exactly what's happening now in agriculture and soil. You take chemicals more than needed. So how to make it more precision? So in the next 5 years, what we expect is um, the usage of chemical fertilizers is going to go down quite significantly, but not because um, structurally we just disrupting it, but it's more of because the soil is healthier, so you don't need that much. Basically, you need it just to boost it, to boost some things here and there, right? That alone is going to decrease the chemical footprints of around 40 to 50%. So that's what we're expecting. And the second is basically in terms of fungicide, pesticide as well. One of the most potent compound in the pesticide is basically glyphosate. It's very potent. I think a lot of research already covered this on how it's cancerous um, and um, and yeah, basically not good for the environment overall. So what we expect in terms of fungicide and pesticide, we would be able to decrease it um, pretty much significantly. Basically, if you don't need fungicide or this chemical, why do we use it? If your crop is healthy enough because of our product, and your soil is healthy enough because of our product, then you don't need that much of chemicals. So we hope that that's gonna significantly reduce. And obviously, all these chemicals they have their own value chain with their own carbon footprint as well, right? So hopefully that's going to go down as well. Um, and maybe just additional thing, Timo, uh, when we're talking about this structural changes, what we expect is if we are able to introduce a new way, a better way of growing the crops, and we spark that demand for more sustainable agricultural input, it will create uh, more incentive for big chemical producers, fertilizers, and everything to also invest more in biological. So overall, the usage and the trend for more sustainable products, both in input and output, is going to get better as well.
Yeah. Okay. Building the bridge between science and the market is incredibly difficult. I want to shift to your personal journey as a founder. What is the most important lessons you have learned while bridging the gap between high-level innovation and field application?
Oh, a very hard question. um, the bridging and basically the value as a founder so far. I think what's most important is having the right north star, the right compass. Basically, I guess the most impactful innovation comes from internally driven people, right? Um, and that will create grit inside of you, and that will create relentless executions and the ambitions to make things work even higher. Um, because, like it or not, the journey is not going to be easy, right? I think we discussed about it a little bit before, because one thing is about dreaming, but another thing is about executions. You will bump into problems, you will bump into rejections, you will bump into challenges, and that's inevitable. And as a founder, if you have that grit and that value and that compass inside of you, you will be relentless in facing and interfacing with that challenges. Instead of breaking you, those challenges will build you up, right? And I guess that's the most important lesson, I would say. Trying to find that inner strength within you to basically becomes the fuel to keep you going.
Okay. And as you also mentioned previously, yeah. So one thing is the innovation itself, right? So you can have the tech in place,
Yeah.
yeah. But once you want to implement it or you want to deploy it, this is another thing, right?
Yeah,
Where you need to
definitely.
check, okay, how will be then the feedback from the market itself, yeah, right? So
Correct.
this should also match definitely, yeah.
Definitely.
Okay. And then also for the so-called advice, right, for life, what I understood now, or for our audience of young innovators as well. So your message was when it's a journey, yeah, it's a journey, yeah. Everything can start with a dream. Sometimes you have some challenges on the way,
Yes.
but really keep going, yeah, keep going, and this is then the way how you can handle these challenges, yeah.
Yeah.
Perfect. Thank you so much, Abu, for sharing your vision with us, yeah, on the Indo-European Bridge. It has definitely been a pleasure. Where can actually our audience learn more about Tana Makmur, yeah, or connect with your company?
Yeah. We are available on Instagram, for sure. Tanalab .id. Basically, check them out. Second, you can just visit our website. It's www.tanastriplab.com, basically. So that's where the informations are. And yeah, hopefully we can collaborate, basically.
Perfect. And of course, we will also put then the contact details of your company in the
Oh,
show
yeah.
notes below, so that people can reach out to you and collaborations can happen.
Yeah.
Yeah. Thank you so much.
Thank you,
And
Timo.
yeah, see you on the next episode.